on page 127 when we're done. So we've been talking about geometric sequences and series, and we talked yesterday about arithmetic series. So remember, the sequence is the list of the numbers, the series is the sum of the numbers. So a geometric series is just the sum of a geometric sequence. So just like with the arithmetic series, we do have a formula, so we don't always have to list everything out. This formula for a geometric series looks like this. S sub n equals big old fraction a sub 1 times 1 minus r to the nth power over 1 minus r. So n is the number of terms still. A sub 1 is the first term. Remember, that doesn't always necessarily mean it's literally a sub 1. It means the first term that you are using in your series. So depending on where you start, you got to start with that one. And then r is the common ratio. So for an arithmetic series, we needed n, we needed a sub 1, and we needed a sub n. We needed the first term and the last term. So n, the first term, and the last term. For geometric series, we need n, the first term, but we don't care about the last term. We need the common ratio, where we didn't need the common difference for arithmetic, but we need the common ratio when we do geometric. So still three things, but it's not the exact same three things. Let's do a couple of examples here. If you have the series, if the sequence is actually listed out for you, then you do start with the first term. This right here gives you n, right? N equals 9. So a sub 1 is equal to 2. We don't care about a sub n, right? We don't care about the last term. We need the common ratio. What would the common ratio be here? 5. Okay. 5. So then we substitute it in. I want the sum of those 9 terms. That's equal to 2 times 1 minus 5 to the 9th power over 1 minus 5. Go ahead and type that in, and I'm going to have somebody tell me, I will choose somebody to tell me the answer. All right, Sarah, when you get an answer, let me know what you got. $562, y'all agree with that? Yes. All right, any questions about that? Let me just tell you, last period when I called on somebody, they gave me negative 976,500, and I thought, that's weird. Like, how did you get so close, but it's negative? So went over there and looked at her calculator, and by the time I got there, she figured out what she did. She put a positive 4 down here in the denominator, okay? Now, is that a pretty basic mistake? Like, it's just, anybody could do that, right? And so clearly she knew what she was doing, right? But when she typed it in, she just decided to go ahead and do that 1 minus 5, but she did it wrong. Like, probably the easiest part of everything we're going to do today, and she did it wrong, which I'm capable of too. I mean, no shade on her or anything. I'm just saying that, first of all, if this was on the AP calculus exam and this was the final answer, you could leave it like this. You wouldn't even have to type it in. But if you are going to type this in, this is why I say first step is zero work. You just write it, you just substitute things in, because we can do simple things very, very wrongly. So even when you type it in, sure, putting negative 4 is fine if you actually put negative 4. But if you just type everything exactly like it is, you let the calculator do all of that, and you're not going to make a ridiculous mistake. Does that make sense to you? Okay. All right, so then let's see. Then you do, so for number 2, I want you to go ahead and find n, find a sub 1, find r, and then we'll make sure we all agree, and then I'll let you do the rest. right, next, what'd you get for n? 8. Okay, what about a sub 1? 72. What about r? Negative 1/2. We agree with all of that? Yes? Awesome, thank you. Go ahead and find the sum. And in this case, since we don't have any decimals, we're working with fractions, your answer would be left in a fraction. Daniel, when you get an answer, let me know what you got. Getting some errors. Okay, look at your parentheses right there versus mine. Oh, I think you're, oh, I know why. Go back. Oh, the arrow up. Oh, maybe not. Okay, well, try again. Make sure that you're using, so you have to use a minus sign here. You have to use negative signs here. They're different. Good, you got it. You're not the only one typing a bunch of times. Did you get it? No, because now what you're dividing by, if you arrow over, you're dividing by that 1. You had, it was fine where you had typed it before. You just didn't hit enter. All right, so what you should get is 765 divided by 16. Okay. Gotta watch your negatives and your parentheses and your exponents and all that good kind of stuff. Okay, we good? What questions we got? All right, let's look at number 3. This symbol here, what is this? Sigma. Okay, that means it's your summation notation, right? Okay. So here, what is n going to be? No, it's not 1. 7. N is 7. So the first term, a sub 1, would be equal to 3 times negative 4 to the 1 minus 1 power, right? 1 minus 1 is 0. Anything to the 0 power is what? 1. So what's a sub 1? 3, not 1. And then what is r? So remember when we found the terms for the geometric sequence? We had a sub 1 times r to the n minus 1 power. Right? That's your little formula for the geometric sequence. That is what we have right here. So what is r? -4. Not only that, but we didn't really have to do all that because there's a sub 1 right there. Okay? Work smarter, not harder. And so now that we have all of that, we can find the sum of those 7 terms. Okay? And that's going to be equal to the first term, which is 3 times 1 minus -4 to the 7th power over 1 minus -4. I would also highly suggest on these calculators, hit the fraction button before you start typing. Then you can put stuff in the numerator and stuff in the denominator, and you don't have to worry about weird parentheses when you divide. Here's F. What did you get? Okay, 9,831. You'll agree with that? All right. Any questions? We good? All right, we're going to skip number 4. So, on number 5, what is in? 13, 12. No, I don't know. What is it? It's 12. So it is 12. What is a sub 1? 7. What is r? 3. Do we really care about a sub 1? Where are we starting? 2. So remember, your first term is the first term you start with. So yes, a sub 1 is 7. That is a true statement. However, I really don't care. My first term is actually a sub 2, which, oops, let me do it differently because I don't have any room to write there. It's actually a sub 2, which would be 7 times 3 to the 2 minus 1 power. Well, 2 minus 1 is 1, so it's 7 times 3, which is 21. Everybody understand why we don't care about a sub 1? Yes? Okay. All right, so then we need to find the sum of those 12 terms. So you go ahead and, oh, actually, never mind. We're going to skip that on this one. We don't need to do that because we don't need to do every single one. That's all I wanted to do on number 5. On number 6, I just want you to do all of number 6. So basically, let's go ahead and I want you to find n. Do we care about a sub 1? No. So we need r, and then we need a sub 5 to move forward. So find those 3 things, then we'll see, we'll make sure we all agree, and then we'll move forward. Holly, what'd you get for n? 8. You'll agree with that? Yes. What'd you get for r? -5. What'd you get for a sub 5? 125 over 4. Do we agree with that? Did we all get positive 125 over 4? Okay. I don't know if I believe you, so let's make sure we write this down. If I have 1 over 20 times -5 to the 5 minus 1 power, right? That's an even exponent, so that's what makes this positive. If you got -125 over 4, you are not pushing the buttons correctly in the calculator, and you're not paying attention to your parentheses. Okay? It is +1. You were correct. Nothing wrong with what she said. I just wanted to make sure. Usually there's somebody that can get that. Okay, so now that you've got that, go ahead and find the sum. Okay. Fatima, once you get an answer, let me know what you got. Okay. Okay, negative 2,034,500. That is correct. Thank you very much. It felt wrong, but it's right. Well, where did the negative come from? Okay, so negative 5 to the 8th power is going to be that's going to make it positive because it's even, right? And that's going to be a big number. So 1 minus a big number makes it negative in the numerator, and then this down here becomes positive, so that's where your negative over positive comes from. Again, I say you probably didn't have parentheses correct around this part right here, and that will cause you big, big problems. Okay? Because remember this, negative 5 to the 8th power is different than negative 5 to the 8th power. Those are two completely different things. The calculator does not see it like you think it's doing what you're telling it to do. You're the problem, not the calculator. Okay, we good? Okay. Let's look at these applications. So a grocery store started raising money for local schools. In their first month, they raised $4,000. Each month after, they raised 1.5% more than the previous month. Find the total money raised in 4 years. Okay? So how much money did they raise? So we need N. Is N 4? No. It says 4 years, but our data is in months, right? So what is N? 48. That first month, our initial term is 4,000, right? I don't care about the last term, right? But I need R. What do you think R is? 0.015? Do we all agree with that? What if I was to tell you that is not correct? It's what? 1.015. If I take $4,000 and I multiply it by 0.015, that tells me how much more I raise the next month, right? It doesn't tell me how much I raise that next month. Because the next month I raised 4,000 plus that extra, right? So each month you're actually getting 101.5%. Does that make sense to you? An increase of 1.5% is 101.5% of your previous month. So that's why, yes, this should be 1.015. Good catch. Okay. We good with that? All right, so then y'all go ahead and find how much they raised total in those 48 months. And in this, we're talking about money. So would a fraction make sense? No. Would 3 decimal places make sense? No. So do what would make sense since we are talking about money. Daniel, once you get an answer, let me know what you got. Very good. So we've got 278,260.88, right? 2 decimal places, what makes sense here? It's an application problem, so we need to write a sentence, at least a sentence. You can just rephrase the question. It says, find the total money raised in 4 years. So I can say the total money raised in 4 years was, and you need a dollar sign, $278,260.88. And the dollar sign goes before the amount, not after the amount. I don't know why that's confusing to some people, but questions we got? We good? Okie dokie. So let's look at old Carol here. Carol wants to be a millionaire, don't we all? If she saves 1 cent on the first day, so she saves 1 cent on the first day, 2 cents on the second day, 4 cents on the third day, and so on, how many days will it take for her to save $1 million? Okay, so we're not looking for what the total is. She wants to save $1 million. We're looking for the number of days. So what we are looking for is n. We don't know n, that's going to be our unknown. Okay? We do know that the sum, S sub n, which we usually don't know, is 1 million. What is our first term? 0.01, because it's 1 cent. 0.01. What is R? 2, because we have 1 cent, then 2 cents, then 4 cents, and so forth and so on. So R is 2. Okay? So into our formula, which is that S sub n is equal to A sub 1 times 1 minus R to the nth all over 1 minus R. Okay, that's our little formula. We're going to substitute in everything we know. This time we know this. It's $1 million, right? So I have 1 million, 1, 2, 3, 4, 5, 6 zeros, equals A sub 1, which is 0.01, times 1 minus 2 to the nth, because we don't know n, all over 1 minus 2. Everybody understand where everything came from? Okay, now flip your calculators face down. We're not touching them for a while, because we got a lot of work to do before the calculator helps us any. 1 minus 2 in the denominator becomes -1, right? So in order to get rid of this -1, I can multiply both sides by -1. So this is going to give me -1,000,000, 2, 3, 4, 5, 6, equals 0.01 times 1 minus 2 to the nth power. Okay. All right, so now I want to divide by 0.01. What is 0.01? 1 what? 100th, right? So this is 100. If I could rewrite this, I'm not going to bother rewriting it, but I could rewrite this as 1 over 100, right? So couldn't I just multiply both sides by 100? Is that easy to do? What do you just add to the end of a number? 2 zeros. So I have 6 zeros. I just make this into 8 zeros. So -1, and then 1, 2, 3, 4, 5, 6, 7, 8. That's equal to 1 minus 2 to the nth power. You can put the commas in there if it helps you keep up with your zeros. Okay. All right. So now, what's the next thing I need to move? The 1. So I want to subtract 1 from both sides, right? This is already negative, so this is going to become negative 100,000,001. So negative 100, 0, 0, 0, 0, 1 equals negative 2 to the nth power. So now what do I want to get rid of? The negative. So I'm going to multiply both sides by a negative, so this gives me positive 100,000,001. And that's equal to 2 to the nth power. Now, how do we get an exponent, a variable, out of the exponent? What's the inverse? What? A logarithm. The inverse of an exponential is a logarithm. So I can take the log of both sides. And I can use the common log, or I could use the natural log. It doesn't matter. But moving forward, natural log is going to show up way more than the common log does. So we're just going to go ahead and use that, because you can really use either one of them. So I'm going to take the natural log of both sides. Natural log of 100, 0, 1, equals the natural log of 2 to the nth power. So I did that because I want that n to come out. Now that I have it in log form, this n gets to come out in front there. Remember, that's your little exponent rule. So now I have the natural log of 100,000,001 is equal to n times the natural log of 2. Everybody with me? Just very basic log rule there. I want to get n by itself, so what do? Divide. So n is equal to the natural log of 100,000,001 divided by the, don't touch your calculator yet, the natural log of 2. Okay? Now, what does n represent? The days. The number of days what? It takes to get $1 million. Okay, so nobody's punched anything on their calculator, right? I want you down here in this little corner right here somewhere. I want you to make a prediction without saying anything to anybody. I'm not going to call you out. This is between you and yourself. Make a prediction of how many days you think it would take doing what she's doing to save $1 million. Keep it to yourself, mouth closed. Make a prediction. It's only for you, so you can write it small or you can write it light, just to see what we're thinking, okay? Everybody got something? 5, 4, 3, 2, 1. If you don't have something, write something right now. All right, now type that in your calculator. Did you find it, the LN? Does the answer surprise you? That's good. 26.575 is what the calculator gives you, right? So somebody said they guessed 35. Anybody else get close? 30. How many of you were like way off? Because way off makes more sense, right? Kind of logically. Okay. But this is why, so this is an exponential growth, right? Exponential growth, that's what happens. Like it starts off and then boom, it just goes crazy because you keep doubling big numbers. Okay, good. So then we need to write our answer. How many days will it take? So it will take 27, because we're talking days, right? 27 days to save $1 million. Now you probably might be thinking, oh, I can go home, I got some pennies, I can start doing that. But you got to have enough to actually get to $1 million, right? You got to have the pennies to save. I'm more in this negative right here. This is more where I live, I think, instead of the positive, but it's what it feels like anyway. All right, are we good? What questions you got? All right, I'm also going to give you this little half sheet so you can go ahead and get that taped in. Then you can tape in as well. We have one that we haven't talked about yet that we're talking about on Monday. On the test, I haven't decided yet if it's going to be like on the test or if I'll give you a separate one like I have before, but you'll have the formulas. There's no reason. There's things that are important to know. These things, you'll have formulas for them.